There are a few probability questions on this revision paper, not many. So if we go through the ones that are on here and there's still gaps in knowledge, then absolutely, once we've finished this paper, we'll look at some more in-depth probability early on next week. So I'm going to go to, oh, this was the first one, wasn't it? I mean, the thing of the probability is it's based out of 1. So if we flip a coin, there's a head and a tail, but we've got a coin. So that coin is 1, and the chance of it landing on a head is, it's a half a chance, and it's 0.5. You've got, it's going to either land on the head or the tail. It's going to land, so it's going to either land on a head or a tail. So with a coin, it's quite simple. With, I don't know, if we were to have 20 Skittles in a bag, 6 red, 6 blue, or not blue, purple, and different colors, then the probability would be based out of 20. So whatever number that we're working on, it's based on that. So a coin, we flip it up, it can land on one side or the other, so it's out of 2. With a bag of Skittles, there's normally about 20 Skittles in a bag, so your chance of picking a yellow one out or an orange one out will be out of 20, or how many Skittles are in a bag. So probability is based on the chance of that occurrence happening. If we look at this question, it's a bit of a do and then work out the probability of a question. Sorry, got it. Hi. Oh gosh, right, my glasses. Now I'll smudge my glasses. That's okay. Let's get that sorted. Right. So the first thing we have to do on this question is fill out the table, and we're filling out the table as we would. Can I actually? Oh, I can't write on this one. Oh, it's because I've changed it into a PDF, haven't I? So we're looking at straight number multiplication when it allows me my pen to come. Here we go, green. So we're looking at multiplication, and you can see if it's a minus times by a minus, it becomes a plus. Okay, and I always think of it as being, well, if that number goes over to that side, literally, it becomes a plus. 2 minuses. And if it's a minus times a plus, the minus wins, it's still a minus. Obviously, if it's a plus times a plus, it keeps as a plus. It doesn't suddenly change to a minus. It's weird, because minus times a minus is a plus. And then obviously the other way around will be plus times minus, which would obviously stay a minus. So let's have a look at filling this table in. We've got 4 times 11, quite straightforward, times tables, 44. We've got a gap here, 2 times minus 9. 2 is a positive, minus is 9, so 2 times minus 9, it stays as a minus 18. 4 times minus 5. Well, 4 is a positive, minus 5 is a minus, so that stays, go minus 20. We've got some spaces here, minus times a minus, there we go. So we now know that when it's a minus times a minus, it goes a plus. So we've got 6 times 9. Well, 5 times 9 is 45. And then so we've got a 6th one, that'd be 54. And if you weren't sure about these ones, it's non-calc, but just write your times tables in columns here. You're absolutely fine. You're allowed to do that. Minus 6 times 11, minus times a plus, stays minus 66. And we got 2 more to do. 8 times minus 9. It's a minus and a plus, so that's going to be a minus. 8 times 9. So 9 times 9 is 81. So we take away 1 lot of 9, that's 72. And then 8 times 11 stays as a plus. We've got all our numbers in the table. So we've done the first part of the question. Complete the table. Alex says that the probability the score is negative is 0.5, which means there is a 5% chance of that score being negative. We've seen a question like this before, and it wasn't quite like that. But this was a question on its own. Well, we know that 0.5 is not 5%. So it's not a typo. It's a question in the maths exam, which is really quite Not tricky, but it's just a little bit. Yeah, when you're under pressure in the exam, you're thinking, oh yeah, it's just a typo. Well, no, it's saying why is he incorrect? Well, 0.5 is not 5%. It is 50%. Because the half is 50% is 0.5. Or we could say the other way around. 5% is not 0.5, it is 0.05. So we could word it that way around. So let's go on here. We could say the same here. Look, we've got 5 in 100 is 0. Oh gosh, I've done it the wrong way around now. 0.05. And no, I'm not doing that. I need to have it the right way around. I was just going to be lazy, and that's not fair. 5%. Which is 0.05. And as we look at this fraction here, 5 out of 100, we know that 100 is divisible by 5, and the reason we know that is because it ends in a 0. Any number that ends in a 0 or a 5 is divisible by 5. So we can divide our 5 100ths into smaller pieces. We divide 5 by 5, and so we get 1. We divide 100 by 5, or if you're thinking about, oh, can I divide 10 by 5, which is 2, and another 0 on the end, so it becomes 1/20th. So 1/20th is 5%, which is 0.05. So Alex is incorrect because 50%, 0.5 is not the same value as 5%. And then this is the probability question. So after all that, we get a probability question to finish off. And probability often is a question that's you've done some more work, you've done some bits, and then you've got a bit of probability at the end. Because it's hard to build a big probability question up. So we've got Alex picks one card from each set. So he picks a card from this one and a card from that one. What is the probability that the score is 14? Well, I see 14 once. I don't see 14 anywhere else. Okay, so he's got one chance of getting 14 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. So there's 16 different combinations, and only one of them is 14. So the probability that his score is 14 is one chance in 16. Had he have said something like, what is the probability that the score is, can we put a negative? So same question as that one, but it's what is the probability that his score is going to be a negative? We look at all the negatives. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8. I'll still have 16 because there's 16 numbers. And as we can see, that number there is divisible. We could divide it by 8 straight away, so we know it's 1/2. But if we divide it by 2, because we didn't see the 8 straight away, that becomes 4 and 8. And then we can divide it by 2 again. That becomes 2 4s, and we divide by 2 again. That becomes 1/2. But we should see that number and think, oh yeah, that's half of that number, so it's 1/2. So rather than do the 3 steps, we can do it in one. So probability question, we're looking at bottom number is all the outcomes put together, and then the top number is your choice. Or if it's like here, if I'm going to create another number, create another outcome, sorry, a negative, you're looking at all those numbers that are negatives. Right, if we go to the next one, it might, oh, so this is the probability tree. Probability tree, and the only thing I would say you need to remember in the probability tree is that the crocodile, so we're not talking big number and eating a bigger number now, this is another crocodile, that adding both together has to equal 1. So adding both together, all 3 here, look, 0.6 add 0.3 add 0.1 equals 1. 0.5 add 0.3, add another number that we're going to put in here is 1. So we'll do the first one first. So 0.7, and you're getting 2 points for filling in this table. Add 0.3 equals 1. So we know that 3 add 7 is 10. So 0.7 and 0.3 is 1. So the number that goes in here is 0.3. And this one here, look, there's 3 options. We win, we lose, or we draw. So we got 0.5, add 0.3, that's 0.8, add 0.2 equals 1. So that number is 0.2. So we've got 2 marks already because we've filled in that table. The probability that team A plays on an artificial pitch, I was going to scroll down, I don't know why, is 0.18. Why? Well, when we're doing outcome 1, so outcome 1 is he plays on an artificial pitch, so that's 0.3. And the next probability, as you see there, I put a multiplying there. So if it's a dual kind of occurrence, you multiply outcome 1 with outcome 2. So outcome 2, he says here, and wins the match 0.6. And when we're and this is a calculator question, so we can use a calculator if you wish, but when we're multiplying 0.3 by 0.6, it's not 1.8. It is, as it shows here, 0.18. So that's what it's in here. The probability of artificial pitch and wins. We can see artificial pitch and wins. Right. If the probability that the team plays on grass and wins the match. So if he plays on grass, that's artificial. Let's put here at E. So we'll put here grass. Well, we'll put grass at the top. Grass is at the top. Okay, so winning on grass. So we're going to play on grass first at 0.7. And winning, second outcome, is 0.5. 0.7 times 0.5. It's not 3.5 because it's not 7 times a half, is it? It's 0.7 times a half, so it becomes 0.35. So when it's a double occurrence, we're multiplying them by one another. So when you see people on TV rolling a double 6 in like roulette, it's like, oh my god, I rolled double 6. That's a hard thing to do because of a double 6. So on the first dice, you've got a 1 in 6 chance of getting the 6 because of 6 numbers, and then on the second dice, you've also got 6 numbers. So it's a 1 in 6 chance. So to get them both landing on 6 is a 1 in 36 chance of doing that. So if you think about when people roll a double 6 in any game, Monopoly or whenever you're playing board games, that's quite a good, 1 in 36. If you roll double 6, you're on to a winner. You're doing well. So that's a dice. Obviously, there's 6 sides. If we're talking about if we've got a pack of cards, so there's 52 cards in a deck. If we get a red card out of that deck, well, half the cards are red out because they're half of black spades and spades and clubs, and then half a red, hearts and diamonds. So if we pick one card at random, it's going to be half a chance it's going to be red and half a chance it's going to be black. So it'll be 26 in 52, which is a half. If you think about what is the probability of us picking an 8 out of that deck, it's still out of 52. So I know we've digressed a little bit here, but there's 52 cards. There's 1 ace for clubs, 1 ace for diamonds, 1 ace for hearts, and 1 ace for spades. So it's 4 in 52. So that can be shrunk, can't it? Because that can divide by 4. So that divides by 4. So we got 1 in 30. I did buy myself some cinnamon the other day, but I just don't want to put it on my plant that it dies. It's quite old. Right, so 1 in 13 chances of us getting an ace. So the top number is what you're picking out, and the bottom number is the total. So that's probability tree. If we look at, does it say something about a fraction? No, we didn't say, did it? I'll say, does it say show it as a fraction? Not yet. Okay. Oh, this one does that. There you go. Spoke too soon. Marcus makes tables to order. The tree diagram gives information about the probability that the table ordered will have a rectangular or a circular top. And work out, and when it was made from oak or beech, work out the probability that a table ordered will have a circular top and be made from beech. So we just had above where we're talking about double occurrences. So it's first occurrence times by second. Here we've got fractions. Here we've got fractions. So we've got, where we got, what is the probability? What the probability is made from beach. It's made from beach is where we got. Where's the made from? Made from beach. So it's going to be a circular top. 4/9. And 4 was rubbish there. 4/9. That looks like an arrow. Got to be looking good. 4/9. That's the first occurrence. Look, and we're going to multiply it by the second occurrence. So when we get down the tree here, that it's going to be made from beach. 2/3. When we're timesing fractions, it's really easy. There's no work to be done whatsoever. We literally look at that fraction and we go along the top. So we've got a 4 times 2, an 8, and 9 times 3, 27. Okay, so when we're timesing fractions, we don't do anything with flipping or changing the denominator. No need. Just literally times it as you see it, and that is all you do when you're multiplying fractions together. And as we can see, this number, so that's an even number, so 2, 4, and 8. That's an odd number, so 2, 4, and 8 aren't going in there. That's the 9s, the 3s. So that's as simple, sorry, not small, as simple as it gets. That's the answer for the fraction that Marcus has a circular table made from beach. And the probability that Marcus needs to make, right, the probability that Marcus needs to make 6 chairs for a table is 37. That's a random question, isn't it? It's nothing to do with probability as such. It's asking you to convert 37.5% to a fraction. Simple as that. Well, the simplest way to say that number is, first of all, put it as 37.5 parts over 100. That is the most simple fraction you can get, but it's not a proper fraction. And the reason it's not a proper fraction is because it's got a decimal place right there. We're not allowed decimal places in fractions. So the easiest thing we can do is double it to get rid of the decimal place, but we must double the bottom one. So it becomes out of 200. And don't forget, whatever we did with that one, we must do with that one. So 37 add another 37 is 25. So we've now got 75 out of 200. And that is the fraction you could write. You could also, you'd get a point if you said, all right, I'm just going to times that by 10. And I've got 375 over 1,000. That's another fraction. That's quite simple because we've just times it by 10 to get rid of the decimal place. So either of those answers, you would get the 2 points for it. I think that was the probability questions, right? And what I did say, Rebecca, is before you arrived, if there's more probability questions I can find, I'll probably stick with them on Monday, and we'll have a go at. I'll record them on Monday. So what I'd like to do, I'm going to go backwards actually from these, because I recognise some of these questions that we've done just last week. So if I look at these ones, we'll kind of work backwards through some of these questions. We might meet where we've already got some of those questions we focus on, some of the hard ones. Right, here's the information about for another car. Oh, so we can't do that one first, can we? Can we? Here is the information for another car. Engine size is 2.3 litres. Okay. Average fuel consumption is 36 miles per gallon. Plot this information on a scatter diagram. Okay, so we've got here, let me just blur my background 1 second. Okay, right. So we've got 2.3 litres of fuel. So we're going to go up at 2.3. Up at 2.3. So on this graph, you can see that there's 5 spaces between 2 and 3. So that means that each little space is worth 0.2. So we're looking at in the middle of that one. We're going up, And what does it say? 36. Oh, I think I've already done this question before. Look, I'll put it right on there. Okay, so that's really easy. It's that one there. That's already been put on there. I must not have rubbed it out. Draw the line of best fit. I've also done that as well. Look, so the line of best fit. If we're drawing a line of best fit, we have to go as close to as many of the plotted crosses as possible. We don't have to touch any. We don't have to touch any of the crosses. You don't have to go through any numbers here. You don't have to go through 0. It's just got to be as close, obviously a straight line, as close as it can be to as many of the plotted crosses as possible. So we've done that part. I must have clicked enter. So this time we've got 2 points already. Great. Michael buys a car with an engine size of 4.2 litres. Okay, 4.2. I'm going up there. Use your line of best fit to estimate the average fuel consumption. Oh, I must have pressed like enter on my on when it was PowerPoint, because that is the answer. So we're going to go up at 4.2. Going to go up there, look, and we're going to go along to here. And as you can see, depending on where you've drawn your line of best fit, so I've just gone up at 4.2 and I've hit the line, my line of best fit, and I've gone along and it says 24. Okay, so 24 would be my line of best fit. Miles per gallon. However, had you drawn your line of best fit a little bit different, say you're drawing yours, I don't know, let's go a little bit, no, not that bad. If you'd done your line of best fit somewhere a little more like, oh, why have I done that? How could I do that? I'm trying to draw something different. I've drawn it exactly the same, but it's a different curve. Right, if we'd have gone, let's go from here. Right, if we'd have gone there, we'd have gone up a little bit further, and we're going along, and it'd be 26. So like the examiner don't look for 100% accuracy. There's no exact answer when it comes to drawing a line of best fit. So they give you some leeway. So they're saying that if your line of best fit had been quite steep from here, then they would have accepted. Obviously, it would have hit the line a bit lower, 22. Had we, like I tried to do one before, a little bit more flatter, then it would hit the line a bit higher. So they're giving you a leeway in between. Okay, what sort of correlation is shown in this scatter diagram? If we're on an uphill trajectory, things are looking up. So things looking up. When things are looking up, it's positive. Life is positive. When things are on a slippy slope down, oh, we're not going to get to go around them. A slippy slope, things are negative. Yeah, whether that goes without saying, it's not a mathematical saying, is it? So if things are on the up, we're going that way, that's a positive. Things are on a slippery slope downwards, it's a negative correlation. So we're looking at the two different options there. And as I can see, I've already ticked negative. So yeah, not very good at that question, was it? That I've kind of spot all the answers. Oh, that's why. That's why, because it says answers there. Nobody shouted out to me, did they? It says answers there. I've already written the answers. So it's the same for this one. And it's got it here, look. Quite, like I just said, slippery slope. Things are on the up. And if it's random, like really random, there is no correlation. And what it means by a strong correlation or a weak correlation is dependent on the angle of the slope. So if it's flat-ish, but it's still going up a little bit from left to right, it's a weaker positive correlation. And likewise, if it's going slightly down from left to right, it's a weaker negative correlation. But you will not get asked, they won't be so specific in an exam question. The exam question will be, if you get asked that question, it's noticeable that it's going up and noticeable if it's coming down. So you'll get asked that question. Hopefully, right, that's not the answer. We've done that question. We've definitely done that question before. The sphere, there's never ever been a sphere question with NCFE. Never ever in the whole world has there been a sphere question in NCFE. This is a Pearson question, so I don't see the point of doing this question purely because it's not part of NCFE's curriculum, so we won't do that one. We're going to try and find a question. Right, we've done. I'm looking at. So where did we get to last time? Let's look at where we got to last time. Circle, ramp. We didn't do that one. We didn't do that one. Right. So we shapes. We done those a week or two ago. So this revision session should be handy for shapes. Let's go up to tiles. I'm just trying to find a few questions we've not done. Okay, we have done. Well, it's quite a lot we haven't done. Oh yeah, this is what we got to yesterday, wasn't it? We got to the speed. Yep. That's exactly what we got to yesterday. My writing should start appearing. We were going to look at frequency tables, and then so the last question should be, there we go. So frequency tables, not my favorite when it comes to how many points they're worth in an exam, but definitely my favorite in the fact that every single frequency table is worked out the same way. There's no shortcuts. There's no alternative method. Frequency tables, there's one way to work it out, and if you follow that one way, you'll always get the right answer. Quite often there won't be two additional columns on there, but the first column we always write when it comes to frequency table is midpoint. Okay, midpoint, and I'll explain what that means in a second. And the second one we're going to write on there is total. When it comes to midpoint, we look at this column. And it's the midpoint of those two numbers, because this table is saying that 5 trains had between 1 and 5 passengers on them. It doesn't say how many, that, if one had 1 passenger, another one had 2 passengers. It says there was 5 trains that had between 1 and 5. So we don't know exactly how many people were on that train. So we're going to see the midpoint between 1 and 5. So to work out midpoint, we add together and divide by 2. Right. So 1 and 5 is 6. 6 divided by 2 is 3. And what we do once we've got the midpoint, we say now, right, there's 5 trains with about 3 people on. And when we say about, it has to be an about, because the question even says it's an estimate. It's not a real science. So we've got 5 trains with 3 people on. So we have a total there of 15 passengers. This one, 6 to 10. So we're going to have 6 add 10 is 16, divided by 2 is 8. So with this one, you can see there's 6 trains with about 8 people on. So 6 times 8 is 48. Next one, 11 and 15 equals 26. 26 divided by 2 is 13. So 13. So 12 trains had 13 people on. If we're going to do 12 times 13, we're not going to do it. We're just going to do 12 times 12, because that's 144, part of our normal times table, and add another 12 on there. So 12 times 12 is 144. Add another 12, becomes 156. The last one, 16 add 20, 36, divided by 2 is 18. 18 times 11. I'm going to do exactly the same as what I did a minute ago. I'm not going to do 12 times 13, obviously, but I'm going to do 10 times 18. I know that's 108, so I just stick a 0 on the end, and I'm going to add another 18 on it. So 180 add 18 becomes 198. And obviously it doesn't say no calculator, so absolutely, if you want to do any of these calculations with a calculator in an exam, do so. Right, and then we add up, once we've got all the midpoints and we've done it, all the multiplications of the frequencies, we've got total number of passengers, and it's an estimate still, and we're going to add them all up. 5 add 8 is 13, add another 6, that's 19, add another 8, that's 27. Oh, my 2's a little bit rubbish in there. I can see it, but only just. 5 add 5 is 10, add another 19, and another 2, 21. Okay, I'm going to put my 2 there so I can see it's time. 1 and 2, 3 and 4. Okay, so I had a total number of 417 passengers about, not a science, don't forget it's an estimate, and there were 34 days where I did my counting. So over those 34 days, I had 470 passengers. So on average, about, I'm going to do 417 divided by 34 to find the about number of passengers on that train. And the reason with frequency tables it's an estimate is because there is no, on the parameter ones, there's no exact numbers. So hence why we work out the midpoint for 700. What? Work out the midpoint first, divided by 34. Oh, 12.26. Okay, 12.26. Wow. Okay. And if you think about trains in the countryside, that's probably not far. That's probably that could be real data. That could be real data where there's only 12 people on a train. Believe you me. And so we've done that for the whole of 1 month plus a few days. There was an average of 12.26 estimate people on a train. And the frequency table information should not matter if it's trains to Leeds, if it's 34 days. We're looking at midpoint, total, add it all up, divide it by the total frequency. That is the process. Doesn't matter what we're talking about. It's find a midpoint, times it by the frequency, add all your totals up, divide your total by the total frequency. 3 easy steps, but a bit time consuming. So we're going to have another look at another one. And if you look at this, oh my gosh, is it the same? 1, 5, 6, 10, 11, 15. So as you can see, NCFE or Pearson or City and Guilds don't really switch around too much because it's the same midpoints. And I'm not saying they're lazy, but they're kind of lazy. We've got the same midpoint here again. So 1 add 5 is 6 divided by 2 is 3. 6 add 10 is 16 divided by 2 is 8. 11 add 15 is 26 divided by 2 is 13. 16 add 20 is 32 divided by 2 is 36. Sorry, 36. Did I get the other number wrong then? Oh no, I said 18. Okay. Brain fog then. Right. And we've got a little bit more bigger numbers. So this is students. Look, so there's 20 students got between 1 and 5, 50 students got between 6 and 10. Again, we don't know exactly how many marks each student got, so it gives you about. We can do the first one. We can definitely do that. That's no problem. And we can do the second one. 8 times 5 is 40. So 8 times 50 has to be 400. I think it's safer that we do a calculator for the next two. We could do, if you look before, it's 13 times 12 again. Oh, look, it was 13 times 12, and it was 18 times 11, so it's not quite that one. So 120 times 13, 120 times 13, and somebody gets paid to write these questions. That'll be not my ideal job, but I could do it. I would do it. I'd make them more interesting, I think. I think I'd have, yeah, different. Right, and then 18 times 60, so we can do 6 times 18, so we've got 60 times 18. Sometimes when it comes to times tables, it's about making things easy for yourself. Okay, so now we've got a total. We haven't got a total, we've got a total for each row. So we're going to add all our totals up. So 0, 0, 0, 0 is 0. 6 add 0 add 6 is 12. Add another 0 is 20. 4 add 5 is 9. Add another 2 is 11. 1 add 1 add 1 is 3. So we had a total marks of 3,100. And there's 250 students. It says that in the line of the question. If it didn't, we add these numbers up here. So we've got 20, that's 70, that's 190. So yeah, it's 250. So we're always dividing by the total of that frequency column. Always. So we're dividing by 250. So we're going to look at the exact. This might not even be a question. I've just actually gone off and done my frequency table. I didn't even read the question. So 3,100. I'm hoping it's linked. Divided by 250. So we know on average. Wow, that's not very good score, is it? 12.4. Okay. So on average, the students got 12.4. I'm hoping he was actually, gonna. Oh, here we go. In October in the October test, the lowest mark was 2, and the highest mark was 17. In November, the same students took a similar test. The lowest mark was 5, and the highest mark was 18. Mr. Barker wants to write a statement comparing the spread of marks in the two tests. Write a statement. Oh, is Mr. So there's a question. Mr. Baker estimates the mean mark was 12. It's not, is it? It's more than 12. So it doesn't say more than or less than. If it doesn't say more than 12 or less than 12, he's saying it's exactly 12. It's not. It's 12.4. So is he correct? No. It's 12.4. And that's what we can write. It's an exact. He hasn't got more items. So we'll look at these two statements. This one's talking about the range, isn't it? A spread. The spread of numbers, the range. I mean, spread is another range, So we're going to go 17 take away 2 equals 15. So the range in October was 15. The range in November, 18 take away 5 equals 13. So range again. So when we're talking about the range, we touched on it yesterday when we did that one question where I wrote all the different averages. When we're talking range, we sometimes mention this word consistency. We could say that the marks were more consistent in November than they were in October. Or we could just say the range was lower in November than it was in October. You don't have to mention the word consistency because you've told them that you've worked out both ranges, and you can see that the range in November was lower. But using the word consistency shows a deeper understanding, and the fact that you can see that because it's a little bit lower, therefore the numbers are closer together. Mr. Barker wants to write something about. We've done that. Compare spread. Yeah, we've done that. You write something to compare the spread of two magnitude tests. You must show correlation support. Oh, yeah, we've done that. It's for 2 points. Wow, that's 2 points. I thought we were going to have to work out there was going to be another average mark for October, as in like the average mark that they got, but there's not. That's just an actual question there. Is there another frequency table? Oh, we've got it there. Look, it's just range as well. Wow. Okay. And like I said to you before, it does say you can have the right range or you can write most consistent. And oh, yes, he's correct. No, he's not. He doesn't say. I disagree with that. So the reason I disagree with that is because, yeah, maybe because he estimates the mean mark. Okay. So going back up to that where I said no, Mr. Barker estimates the mean mark to be 12. I suppose 12.4 is not far out, is it? But I maybe would have put another word in there to be approximately 12. And then I would have said, yeah, he's actually right. But yeah, I could see. I mean, even if I wrote no and the examiner had seen all my workings out and I'd say no because it's 12.4, I'm not going to get marked down for that. I put all my workings out and I put a statement to say why it's no, because he said it's going to be 12. But then I've misread that information there. But I would have written no. I wouldn't have, I didn't, until I saw the answer, I would have still written no. He's not correct because it's not 12. Is there another frequency table? We've got machines. What is this one? Right, Kieran is a manager of a factory. 7 machines in a factory make tins. The table shows the number of tins each machine makes per day. Kieran needs to order a new machine. The new machine can make 25% more tins than the median number of tins made by 7 machines. Kieran knows that a total cost to make 400 tins is £2.35. Work out the total cost of tins. It's a new machine. Wow. So that's quite when I say complicated, it's quite a lot of.
That's quite a lot of information you have to consider.
We've got to unpack that. Yeah, we've got to unpack it. So my first one I'm doing is I see a word that I recognize there. I see median. Okay, so we're talking small, medium, and large. Middle number when in order. I can do that. I can start building up points towards this. So let's look at these in order. 1, 2, 7, 1, 1, 2, 1, 2, 6, 1, 2. So 1, 2, 6, 9 is the lowest. Done. 1, 2, 7, 1. Yep. 1, 2, 7, 1 is next. 1, 2, 7, 5 is next. 1, 2, 80. Yep. 1, 2, 8, 0. Next. 1, 2, 8, 3. 1, 2, 8, 3. 1, 2, 8, 4. Next. Next. And 1, 2, 9, 4. Right. Quite good because, like most questions, when you're talking about median, there's two medians. But on this one, there's only one median, and it's not that number. So don't think, oh yeah, there's 7 numbers. It's the 4th number along. It's when in order. So we've got a median of 1, 2, 8, 0. When in order, not just as you see them. So he needs to order a new machine. The new machine can make 25% more tins. So we're going to add 25% onto there. We can do that lots of ways. On a calculator, we can simply just say 1, 2, 8, 0, add 25% equals. Straight away, told us. Or we could go 1, 2, 8, 0, change to a decimal, times by 1.25 equals. So we change the fraction to a decimal. 1, 2, 8, 0 times by 1.25. 1, 2, 1, 6, 0, 0. Same number. Or we could find out what a quarter is, because we know 25% is a quarter. So we could go 1, 2, 8, 0 divided by 4 to find out what 1/4 is. 1, 2, 8, 0 divided by 4 equals 320. So equals 320. Then we go 1, 2, 8, 0 add 320 equals 1600. So lots of ways to find out 25%. Whatever way you're comfortable doing, do. So we now know that this new machine is going to spit out 1,600 tins a day. I think a new machine can make more tins than median number of machines. Kieran knows that the total cost to make 400 tins is £2.35. Work out a total cost of tins with a new machine. So that's quite good. If 400, so tins cost £2.35. So this is where it turns from a median to a percentage to a direct proportion question. So we've got 1600 here, look. What do we do with that number to get to 1600? We times it by 4. 4 to 16 is times by 4. So we're going to times that number by 4. So £2.35. £2.35. £2.35 times 4 equals £9.40p. £9.40p. If we weren't seeing that relationship here, not a problem. Why don't we go? And this sounds a bit of a long way round. So we know that 400 tins, we know the cost is £2.35. We could have gone down to 100. So we would go, oh, if 100 tins, that's divided by 4. So I need to divide that number by 4. And then once I got to my 100, right, so £2.35, £2.35 divided by 4 is 0.5875. 0.5875. Once we got to our 100 number, I need to get to 1600 because it says that's how many tins they're going to make. So 1600. Right, now I've got 100. I times it by 16. So I need to times that number by 16. So when it comes to direct proportion, if you don't see the direct relationship between 400 and 1600, then look at if I can work out how many to take 10 machines, 10 tins, 100 tins, 1 tin. What did I do to get it to 100? I divided it by 4, so I divide that by 4. Now I can go 100 to 1600 because I times it by 16. Likewise with that number.
Hello, Steve. Sorry, Steve. Sorry,
Yeah.
just wanted to say, we're talking about exam situation. Is it not just easier if you just divide 1/6 by that 400 and it gives you 4, and then you times it with the number, with the money, the price?
Yeah, you could do that. Yeah.
I mean, I'm just saying, instead of going round and round, because you don't have time to figure all these things out.
Yeah, it's just looking at straight away. I can see that number's 4 times bigger, so I'm just going to times that by 4 anyway. Yeah, but you could do, but you could go, yeah. Oh gosh, that's not going right, is it? Yeah, you could go 1600 divided by 400 times by £2.35.
Yeah.
Equals £9.40.
Hmm.
Absolutely. Yeah, whichever way. And that's the thing with some of these questions. You remember tricks from different questions, and you don't, not tricks, and not even shortcuts. You remember like just little nuggets of information. Yeah, I know, I do that one quickly. So sometimes remember that. You will not be given this in an exam, but as long as you remember that distance comes on top, that's all you need to remember. Because if it's underneath distance, I always treat that as being, if something's underneath it, I've got to divide by it to get to it. But if it's on top, it means I've got to multiply both of those bottom ones to get to the top one. So if you've been asked to work out, and again, it doesn't matter which way around these two numbers go, the S and the T, or the T and the S, makes no difference, because to multiply them both together, you have to get D, and to divide D by one of them, you get the other. So those two letters are not in any particular order, except for alphabetical order, for no reason other than that. So when you're talking distance, speed, time triangle, remember that distance is always at the top, and you should have no problems with those questions. Let's have a look. Oh, no answer. So some of these questions I must have clicked enter on as a presentation, because some of the answers are still covered up, which is not a bad thing. It means we've got to work it out. Is it non-calc? No, it's calc. So here we go. Peter goes for a walk. He walks 15 miles in 6 hours. Wow. Okay, work out Pete's average speed. So if he's gone 15 miles in 6 hours, we want 1. So you can see the relationship there. Yeah, we divided by 6. So we divide that by 6. And simple as that. So 50. Sure, there's no no. Okay, it doesn't say no calculator, so let's not worry about that. Let's just do 15 divided by 6. Done. 2.5 miles an hour. There we go. Pete, you're not working too quick. You're doing all right. So answer for 2.5 miles per hour. Sunita says that Peter walked more than 20 kilometers. Is Sunita correct? Show you're working. It's given us the conversion, as it would if it's talking different units. It will give you the information. If it's saying kilometers to meters to centimeters to millimeters, it won't. It's staying the same, isn't it? 10 millimeters is 1 centimeter, 100 centimeters is 1 meter, 1,000 meters is 1 kilometer. So that's part of the same family. If it's a different family, it will give you the conversion. And if we set it out here, we've got 1 km is bigger than 0.62. We've got 20 kilometers here. So what did we do to that number? We want a bigger number on this side. So if we want a bigger number, we multiply it. If you wanted a smaller number, the bigger number needs to be on the right, left-hand side. We're going to multiply it by the miles. So we're going to get a smaller number to find out. Oh, didn't put an M there, did I? Miles. 20 times by 0.62 equals 12.4. So did he walk? Sunita says that Peter walked more than 20 kilometers. 20 kilometers is 12.4 miles. Yes, he walked more than that because he walked 15 miles. If he'd have worked out the other way, so how many kilometers did he actually walk? because some people might have seen it that way around. Then we'll go same again. Kilometers there is 1, and miles here is 0.62. We've got 15 miles that he walked. So now we need a bigger number on this side because the miles is the smaller number, the kilometer is the bigger number. So we divide it by how many miles are in each kilometer, and then that will tell us how many times that number goes into the bigger number, and therefore how many kilometers. So we've got 15 divided by 0.62. So if he'd done 15 miles, he's walked 24.19. And both way round would have been absolutely fine because you're getting 1 mark for showing your workings and 1 mark for saying yes. So it's only 1 mark to actually show your workings out there. Brighton. Fred is a taxi driver. On Tuesday, he drove to Birmingham. The journey took 3.5 hours. His average speed was 48 miles per hour. Fred wants to drive back in 3 hours. The average speed is 60. Can he drive back in 3 hours without going over the speed limit? Show your workings. And this is a Pearson question because we've got that rubbish part, not rubbish, but we've got that additional, oh, show me how you did it, but go backwards. NCFE don't do that. If you're going to show them your process of going forwards, they're happy, which I'm happy. Cool. So let's have a look. The journey took 3.5 hours. Don't forget, we've got the triangle here. So it doesn't say, does it? So it doesn't give us the D. It gives us the speed and it gives us the time. So we're looking for that D part, and we can see they're both on the bottom. So we need to go 3.5 times by 48 equals, so S times T, well, T times S we done, equals D. So to work out how far Birmingham he drove, 3.5 times 48, 168 miles, 168. And he wants to drive back in 3 hours. Now we've got the D. So we've got the D part now, because that's 168. And he wants to come back in 3 hours. Okay, so we've got 3. We want to know what the speed is. So we've got 168 divided by, he wants to come back in 3 hours, and that'll tell us how fast he's going to have to go if he wants to make it in time. 168 divided by 3 equals 56. So he could go 56 miles per hour and he'd get back in 3 hours. He wants to get back in 3 hours and he wants to go less than 60. He's all right. He can get back because it's only going to take it. He can go 56 miles an hour. So yes, he's correct. Yes, for that one. Right, I reckon we've got time for one more. On this question, I've seen a few on NCFE, and I've seen a couple.
Sorry, how did you do the reverse?
Don't need. So for me, if I'm going to do the reverse, so this is Pearson. So on Pearson, when you do reverse calc, I would say, right, I've got 180. So with my reverse calc, I've got 168. I'm going to go 168 miles. Instead of dividing by the 3 to get my speed, I will divide it by my speed, and I'd get 3 point something. So I've shown them that actually 168 divided by 56 is
the 3.
Yeah, it's the 3. So I just go backwards. I just rearrange those numbers. That's all you need to do. And that's why NCFE don't ask for it, because you've just worked it all out. So reverse is just put it in a different order. It's bizarre. But it's their way of confirming learning. With mass, density and volume, I've seen a couple of questions on the NCFE papers where they've given you the formula, and I've seen a couple of questions that they don't. This one, very similar to the other one, as in like it's 3 measurements, and if you look at one here, we've always got M on top. So if you want M, we're going have density times volume for mass. If you're wanting volume, you've got mass divided by density. It's all about looking at where we've got. So if you look on this one, the dominant letter is M. So M's always on top when it comes to the density, mass, and formula triangle. So it's exactly the same as the speed one, in that there's 3 bits. And the only confusing part here is that there's a D in both. So that's why I think NCFE quite often would tell you which way round it is. They'll say follow this formula to work out the volume. But if you don't get the formula, remember that the M is on top. All right, let's just get this question done, and we are done and dusted. Fatima wants to make a model boat out of a solid block of wood. She needs to find out if the wood will float. The wood block has a volume of 3,800 centimeters cubed, and it has a mass of 2,750. Fatima knows the wood will float if the density is less than 1 gram per centimeter cubed. That's the only thing that gets a bit confusing when it comes to density is if it asks you to give them the measurements. And look, it's giving you the formula here. It gives you the formula. So let's have a look. We've got the density. No, we've not. We've got the mass. Yes, we have. 2,750. And we're dividing it by the volume, which is 3,800. And it will float if the density 2,750 divided by 3,800 is less than 1, 0.723, 0.723. It will float if the density is less than. So yes, it will float. Wonderful. We've got a few more to do, which we'll finish off tomorrow. So that means all this week we've been working on all these revision questions. And what I would say is I've not been sending the recording out. I sent it out, I think, for Monday. I'll send out the last 2 tonight or first thing in the morning. And then tomorrow we'll finish off this revision paper. We've got a few questions to go, mainly my lovely circle ones and my cylinder ones. So if you were in the sessions a few weeks ago or 2 weeks ago, you'll remember some of these questions, but that's not a bad thing because we want to have that memory recall of not we're talking about Kathy or a farmer's tank, but we're talking about finding the surface area of a cylinder or the circumference of a circle. We want to get those processes in place. Right. So I'm going to stop the recording and I'll stop the share.